Okay, today, so we did a bunch of shoulder stuff. So I started with banded internal rotation. I did that 3 times for 10 reps. Then I switched it to banded external rotation, did that 3 times for 10 reps. Then I did shoulder raises, inscaption, flexion, and abduction, 3 times till failure. Then I moved into like a plate raise and shrug, 3 times till failure. And I went to a shoulder protraction exercise with someone kind of like batting your arm around for shoulder stabilization. Did that 3 times for 30 seconds. And then to end it out, I did crazy 8s 3 times for 8 reps. So basically having a plate in your hand and you move it in an 8. And today I'll be talking about the glycolysis process. So you start with your 6 carbon glucose molecule. ATP is added to add an extra phosphorus, and hexokinase is the enzyme that comes in and helps that out. So once that happens, you get down to glucose 6-phosphate. Then again, another enzyme comes in, isomerase comes and changes that glucose to a fructose just by changing its structure. Then PFK or phosphofructokinase comes in and adds another phosphate on the start of that molecule, and ATP is what adds that extra phosphorus. So you end up with fructose 1,6-biphosphate. Then aldolase comes in and splits that molecule in half. So you're left with a phosphate group at the start of a carbon chain, and then a 3-carbon chain with a phosphate group on the end, which is DHAP and G3P. DHAP gets converted into G3P, so isomerase comes in again and changes the structure. Then it goes through a process of adding and subtracting electrons to get ATP production and all that fun stuff. You end up with 4 ATP in total, but since you 2 were added in to create the whole process, so you get a net gain of 2. At the end of the production of ATP, you're left with 2 pyruvates, which are just 3 carbon molecules. And then after that, when you're breathing, you actually breathe out one of those carbons, so you're left with acetyl-CoA, which that can be used in the Krebs cycle.